Hello guys, welcome to this presentation about how to write super clean code in Angular, patterns, architecture and implementation at the feature level, featuring NGRX component store. Title is Just Do It, because I hope to equip you with the necessary information and concepts so that you can go ahead and implement it in the wild. The context. As Angular developer, we have obviously responsibilities to our clients to deliver features that just work, to our team to deliver clear and maintainable code, and to ourselves to constantly improve and be on top of the game. But then, as any experienced developer knows, when you work in any project, you're facing certain risks. Because the complexity keeps being added to the application, the teams keep changing, and everybody writes with their own style, and reaches a point that the code becomes unmanageable, and the app might become unpredictable, and there's always the risk that the project can fail. Or if it doesn't fail, it will stall for years in a miserable state until a good developer comes around and cleans up the mess. Well, you want to be definitely that good developer, but at the same time, you don't really want to be in that situation because it's stressful. So, what can we do about it to minimize the risk of things going wrong? Well, the Angular ecosystem provides us with a lot of amazing tools to mitigate such risk and write really good code. However, tools alone don't work if they are not used within established best practices, and this can be articulated in three things. First is the paradigms and patterns that you're using, which means the approach you have to code. Second thing is the architecture. How you're structuring your code, how you're structuring your coding, your logic, and your files. How you separating concerns. And the third thing is the implementation, which is to say, once you know what you have to do, once you know what is your approach to code, once you know what structure you're trying to build, it is also important to consider how you are doing it, how you are implementing it, following what process, right? So, for what we said, to keep on our responsibility as a developer, we must investigate further how to do this, okay? And I give you my view. So, if that interests you, resonates, and can help you, please follow along this discussion. Let's talk about patterns, paradigms, and patterns. What we want for clean Angular code is declarative and reactive code. That's our approach. And we're going to try to write as little imperative code as possible. Okay? This is the way. Declarative and reactive code. We need to aim for nearly 100% of declarative and reactive code. And the way to do that is using RXJS, of course. RXJS is the go-to library for declarative and reactive code. It enables to encapsulate the logic by declaring data relationship into observables that we then can compose and scale the complexity like to almost infinite level. And still, the complexity will be handled by the relationship that we define between the data. Okay, so when one stream change, the entire data will follow all the relationships and will update. Then we want to use the observables, tapping into them using the awesome Angular tool, which is the async pipe, which is offered in the template, so we don't have to manually subscribe and unsubscribe. Then it is important that all your components, and I mean all your components, must have on-push change detection strategy. If they don't, Angular will have to check any changes in your messy state like every millisecond or something. And this will impact noticeably the performance of the application as a whole. So make sure all your components have on-push change detection strategy for a fully reactive, fast and performant application. Another thing that is important in defining our approach is to avoid writing our custom logic or fancy components and try to use as much as possible what is provided by the framework. For example, reactive forms is an awesome thing. Use them and use the methods that they have. Equally, use Angular material. If for some reason you don't want to use them in your project, you can still use the CDK that abstract the functionalities of the component. Then, at the feature level, you can use NGRX component store for managing the state of your component, of your feature. And we will see this in detail in a second. As we said, we are aiming for 0% imperative code, but to be honest, it's difficult to avoid it completely. Sometimes you will have to write imperative code. Just keep in mind that you want to avoid it. Following this approach to code, it will result in more maintainable code, scalable, more performant, and a code that will be equipped from the start just by your approach alone. It will be equipped to handle a lot more complexity. And you will find that this approach to code it might result slower at first. So if you need to prototype something, maybe you can do it imperatively and get it done faster just to show it up. But if it has to be a production application that needs to handle a lot of complexity, a lot of enhancements, and needs to be maintained, then this is the way to go. This is the approach to choose. All right. Now let's move to the architecture. What do you want to achieve following this approach? You want to achieve a specific architecture at the feature level, remember. We want to have, obviously, our data services, which are global injectable, probably, singleton, that means. Then we're going to have a store for managing the state at the component level. We're going to have a container, and we're going to have a presentation layer. What does this mean? Let's start from the presentation. We're going to have a presentation layer composed of presentation components. These are very simple components. They only have simple input, output, and reactive forms. And they only deal with the layout, defining the layout and the interaction that the user can have with the interface. They absolutely have no logic and no state. Okay? So they don't even know most of the time what the input they receive actually mean. They just know what they have to do with them. Okay, so maybe they receive a certain input, and when they receive it, they know that they need to check a certain checkbox. That's all. They don't need to have a state, so they don't need the data services injected into them, and they don't need any like these variable, right? And you don't need to change a state to any of these variable. You don't have to do things like writing a function where you say this message equal blah 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 or whatever. You don't have to do that. All the variables defined in these classes are input and output and reactive forms. Then we have a container component, which is a bigger component that is going to orchestrate one or more presentation components, passing them values through the async pipe and handling the output events that they will emit. Also, this component will have no logic and will have no state. So no data service injected into it and no these dot variables. The container component is an orchestrator of the presentation and is a communication layer between the presentation components and the store. It initializes the state and updates the state in the store, and it exposes the selectors importing from the store. And we move to the store. For the store, the component store, and we can use for it NGRX component store. It's an awesome library. Basically, this is like a facade, okay? Before this library came out, it was common to manage the state at the component level using a facade with behavior subjects, you know? But now, likely, we have this awesome library that enables us to use to do the same thing, but using cleaner syntax and GRX syntax. And so we can use a state, selectors, combined selectors, updaters, and effects. And the cool thing is that most of the logic is declared by combining selectors and establishing logical relationship between them. Okay, so we don't have an imperative logic, but the logic is encapsulated, is declared lazily and lazily executed and declared in the relationship between the data, between our selectors specifically. And then obviously we need our data service. It's like the last layer. And again, they only need to be injected in the store. The rest of the components need to have a pristine constructor and also a pristine ng on in it, because they don't need to execute anything really, okay? They just need to react depending on the state changes, and this happens in the store. So let's talk a little bit more about the store. As we said, this is a store for components. So we are not talking about the global state, right? We are not touching this global state in this discussion. It is a store for components, so we are at the feature level, and it's going to be a single file, which much less boilerplate compared to the global NGRX implementation. In this single file, we're going to have a state that we can define with different properties. We're going to have a state selectors using this .select method that they're going to expose slices of the state's properties. And these are going to be just observables, so we can pipe them however we want. There will not be real memoization, but still, because it uses distinct until change and shared play under the hood, we can be pretty confident that we will not going to execute unnecessary computation. Again, the cool thing is the combined selector. Basically, with the combined selector, you can use the .select method to combine a state selector or another combined selector to produce another stream, another selector, another observable. And this is where the encapsulation of the logic in form of a relationship between data can be declared by defining the combined selectors. Then you're going to have the updater functions, so you're not going to have actions or reducers. You're just going to have simple updater function. For example, you have the patch state that is going to update a single property of the state, and that's it. You just have to call it patch state, name of the property, and magically it will work. We have effect to isolate API calls, and this is a solution that scales. How does it scale? We say that we use this solution to manage the state of one feature with one file. So when this file becomes too big and difficult to read, it means that we are managing at least two features. So what we have to do is to create another store, create another container, and split the responsibilities between these two stores and these two containers. So if you done this right, you will see that the presentation layer will not even notice, because they only have a simple input and output. You just need to plug them in, and they will work. Now let's talk about the implementation. So how to do this? There is a specific way to do this, and I will explain you why. First of all, you need to do like a minimal setup from the ground up. So start from your data services, just make them exist, okay? Define like a minimal setup. Minimal setup of the store, minimal setup of the container, minimal setup of the presentation components. And this minimal setup needs to be enough that you can run the application with ng-serve without errors, and you're gonna see on the screen my presentation component works. Okay, that's all. Once you have that, then you start building the whole system backward. Okay, you start from the presentation components. You start defining the layout, the interactions that the user can have. You're gonna define the inputs and the outputs. Okay, once you've done that, you take the input, the outputs, and you move that to the template of the container. Okay, so okay, this presentation component needs this input and is gonna emit this output. So that means that I need to have an observable, and so I'm gonna have observable async pipe that plug into that input, and method that is gonna handle a certain output. Okay, so then you write these observable and these methods in the class of the container. Once you have them there, then you know that you need to take the observable that you have in the container. They represent store selectors, and the methods that you have in the container, they're actually gonna update the state through some update function. So you can move these observables into the state, and once you've done that, once you reach that point, that is the moment that you begin to define your state. All right, because you will see that certain observables depends on others, so you should not put them in the state, but you should define a combined selector for those, and so on. So that is where you start spending some effort defining the relationship between your data, defining the state, the relationship between the data, selectors, combined selectors, updaters, and effects, everything that you need. Okay, and again, focus on the selectors and the combined selectors to encapsulate the logic and the relationship between data. Now, why are we using this weird backward implementation? First of all, because when you go backward in this way, you see that you will not have to think about the logic anymore. You will just do automatic wiring. Okay, you will not be bothered by analyzing the logic. You just need to link up inputs and outputs from the presentation to the template at the container level. And once you've done that, you know that the container class needs to have certain observable. Once you know that the store needs to have certain observable and certain update methods. Once you reach that point, this is where you need to start thinking about the logic again. And after you plug in everything, you will see that everything start working magically. And why it does? Because you just wrote exactly what you needed. Everything you ported backward is just exactly what you needed, and of course it's gonna work. If you were working the other way around, okay, instead of implementing this backward process, if you started from the store, you say, okay, let me see what kind of state I need. Or maybe I need this state, and then I need this selector, and then I need this other combined selector, and then you bring these forward to the presentation. When you reach the presentation, you might realize that you actually don't need most of the things that you've written, and maybe you spent one day doing that, and you just wasted time. So really, implement this architecture backward, so you will just have only what you need. And you will see that once this architecture is in place, really complex logic can be added, like really, really easily. Now, let's talk about RNJX because we have a problem here. I know that it's an obvious problem. Like many developers are scared of RxJS. They look at it, they don't understand it, they don't get it, they don't want to learn it because it's difficult. And it is true. There is a really steep learning curve. And let me try to help you here by saying a few things. First of all, don't give up for a specific reason. People that know RxJS will tell you that it's not something that you learn progressively. It's something that you learn like all of a sudden, because like until you get it, you just don't get it at all. Okay, so you just need to hang in there, stick in it, and then suddenly you will have like a realization, you will have a click moment, and you will say, "Aha, this is how it works." Okay, from that moment on, you will start being able to read the documentation, watch example, and learn progressively more and more. And the learning curve will not be at all steep. Okay, so hang in there and wait for this click moment. You can do it. Another thing that can help is like you can skip the theory. So forget about hold and cold, hot and cold observable. Forget about subscriber, observer. Just focus on what observable subject and behavior subject are. I'm gonna give you my take. You never know, it might help you. My little metaphor. What is an observable? Is basically like a promise that can resolve multiple times. Therefore, it gives rise to a stream of async values. Okay, and so imagine this. This is like a source, like a fountain that is dripping, and each droplet is like data. Okay, and you can physically pipe. Okay, with like imagine like with a physical pipe, you can pipe these droplets and into a physical pipe, and inside this physical pipe, each droplet will be transformed through an operator. Okay, this is what you can do with RxJS. Not only that, but since each pipe defines a set of operators or transformation of these droplets, you can actually plug different pipes together and compose, the transformation of the droplets the way you want. Then, if you want to tap into this source of droplets, you use a subscribe method and you can consume this droplet. What a subject is? A subject is an observable, but it has a next method. So you can imperatively actually tell him what to emit. Okay, you can put in the next whatever parameter and it will emit it. A behavior subject is something that it is a subject, so it has a next method, but it always, when you tap into it, it will give you always like the last value that was emitted. So it's like if you open the tap, like a water tap, it will emit the droplet that is the last droplet that was emitted by the stream. Maybe that droplet was emitted 10 years ago, all right? Okay, right. Hope this helps. Let me know. Another tip is learn by doing. Okay, because this is something that needs to click in your brain. Okay, so really like move your fingers on the keyboard on this. Okay, create a test page. Write a bunch of operators in a pipe. Write observable. Console log the results, and this is how you will exercise your brain until you get it. Another thing is that you don't need to be scared of operators, especially of the fact that there are so many. Nobody knows them all. You cannot know them all. And actually, it's a really encouraging thing, the fact that you can build really complex pipes just by a few. And the one I wrote are a lot, probably. Okay, you can build a lot of complex logic, just with a really bunch of them. Okay, with a switch map, filter map, and combine latest, and that's it. Okay, you can use them initially until you learn the next operators that you're gonna use in your arsenal of RxJS Ninja. And let's get there. When you get to be a RxJS ninja, you will feel like you have superpowers. Okay, you will start writing really complicated code. So at that point, you need to remind yourself to chill. Just chill, right? Chill. even if you get really good at RxJS, you still need to write code that is clear and understandable. Okay? Otherwise, it will be difficult for you to refactor it or to add extra complexity. So my recommendation is that you keep it simple, you keep it modular, reusable, and elegant. You can do that by setting some rules, like always have really short pipe chains, don't make them long, because you need to break it down to multiple and reusable observable. And this observable needs to be named meaningfully, in a way that what they represent is self-evident. Okay? So that when you compose them to create like some complex logic, when you compose them, you can actually read and understand what's going on. Okay, like you have filter data, like filter user, then you map them and you get you do a switch map and you get I don't know, the permission, and then from the permission you get I don't know, the books, you know. This has to be clear, and this depends on how you break them down and how you name them. Okay, make it readable, make it simple, make it composable. Another thing that helps is when you have a lot of JS logic, just JavaScript logic, it's good not to have it inside the pipe itself. Okay, but this will make the code like long to understand. So my suggestion is to move this JavaScript logic into a helper function, so that the pipe will be composed of just operators, and each operator will be like one liner or two liners. Each operator must have like data in from the previous operator, transformation to a new observable or new data, and this is gonna go to the next operator. Okay, like parameters out, output, one-liners. Okay, so you can read it easily. And then if you get so good that you can get to know some esoteric or even custom operator, remember to describe what the heck actually they do to the code, right? Have respect of your teammates. All right, we made it. So I really think you have no excuses not to do this, not to pay attention of the kind of code that you have. You're right. You don't have excuses because you have responsibilities, as we said, towards your client, towards your teammates, and towards yourself. So really investigate more on the issues that we mentioned here. Learn how to do it. And I prepared also a hands-on tutorial to give a demonstration on this. So really get on top of this all, and stop excuses, learn it, okay? And just do it. Just write clean Angular code, right? See you at the tutorial, guys. Bye-bye.